So yeah, welcome back. And I aim this to be really interactive in as much as we're going to go through a couple of slides from Phil. So this lecture would have been given by Phil, but I'll do it on his behalf. And we're going to delve into environments and containers and so on, and how to isolate that. So I just want to ask us, how many of us have familiarity with Python, the language? Yeah, lots of us. Yeah, fantastic. Yeah, that's pretty great. And I don't know, what is your biggest challenge working with whether it's Python, mostly with Python? What's your largest, one of your biggest challenges? Kimita? Versions, yes. Okay, someone else, another challenge? Yes? Installing packages. Yes, Jane? Dependencies. Yes. And if you learned Python a while back, we had the migration from 2.7 to Python 3. And you know, that was a big pain for a lot of people. So as a bioinformatician, there's some painful parts, and you know, these are two of them, and we've sort of alluded to them. One of them being software installation, right? And often you're running this on your computer, you always have to be the one to do the software installation. And software installation is not just software installation. It means having a little bit of knowledge on what's going on and under the hood. Sometimes you may have to compile the tool. So most developers will provide you either with a makefile or a to-do list, an installation how-to document, and sometimes then completely non-existent. And if you develop or you write your own package, you write your own script, and you want to share that with your colleague, often that can present some challenges. If it's a C file or a tool, you know, you need to be able to compile it, and it depends on, you know, whether your colleague or your collaborator is working on Windows or they're working on Linux and whatnot, and you've got to think about that software environment. The other one is reproducibility. What does that mean? Anyone? It's a very common term nowadays, particularly within the bioinformatics community, but not just bioinformatics community, across the software world. Reproducibility. Guldeep. What does that mean? Yes. Kimita, wanted to add something?
Being able to do something in a particular and get the same results, not only you, but also someone else using your CPU.
Yes, both of you are correct. So it is ability to replicate or to produce the same exact results given the same input. Okay, and often you think this is, you know, this is easy, but it turns out that software and how you install the software and where you install the software, those dependencies can cause minor changes, and you know, and often if you got multiple versions, you can completely get different results, right? And again, it depends on the sort of what you call it, how granular your results are, or how accurate you want to get them. So a good example I think I came across at some point was if you got a rocket, you know, like the way NASA does, send these rockets to space, you know, in Mars or Pluto or whatever, maybe outside the solar system, and they make all this communication. Precision is everything. It can make a lots of, you know, influence on the result you get and the timeliness. So how far and what language you're using and how that setup is made needs to be really, really, really accurate. Okay? In bioinformatics, we get different tools, we get different environments, and often you're told, well, this, you know, you need some tools, but what version of some tools? Okay, so if I use SAM tools 1.1 or 1.2, which is now outdated, it doesn't use HTS library, maybe I'm about to get different results. But on the paper, sometimes you read a paper, you come across a paper and they say, we use SAM tools to do XYZ, or we use BWA aligner to do XYZ. Okay? So environments and containers can help us solve both of these problems. And I think most environments, particularly in the world of Python, was really important because of versioning. And because I think in the world of Python, how you install tools, I think you got PIP, right? You got setup tools, you got Coda, you got like all these different things. I'm not a Pythonista, I at least respect the language as it is, you know, but I know the challenges, and I work with Python. I've written Python scripts, but I always run into those issues, and this is one way to get around it. So installation, you know, before 2016, what Phil is saying here is that there was a trade-off between the simplicity of making software available and the simplicity of installing software, and that's what I was alluding previously. So how easy do I want to make the tool available, and how easy do I want to make it installable? Okay, and you got to think about these two people. That's the developers and the users. Often, as a bioinformatician, if you're a fellow, if you're an MSc student, if you're a PhD student, if you're a postdoc, at times, sometimes these two morph into one person, and you've got two personalities. You're the user, you're the developer. Okay? And then it becomes difficult when you want to communicate with your colleagues. If you're within a much more resource-endowed laboratory, you will find that they will have academic, scientific software developers who will write the tools, and you'll see the users, who are often the scientific people who want to test their hypotheses, and they will probably work very closely with software developers. More often than not, a bioinformatician is these two. And if your background is in biochemistry, and you came on with, you know, learning how to use make tools and so on, there's always a challenge there, you know, how you close those two, okay? Or how you sort of balance between those two worlds, okay? So scripts have a list of dependencies. So if you see your typical Python script, you know, you start with import numpy as np, import plot as whatever, import bio as b, and so on and so forth. And each of those, so if you import a large package like the BioPython, it comes with tons of dependencies. All those dependencies need to be compiled. So again, those dependencies are dependent on other dependencies, and it becomes hell, okay? And it becomes really difficult to install. So again, when you go about the users, you know, you want it to be easy, and you know, it can become hard. And if it becomes hard, if you're I don't know if you've been in that position as a research officer, and you got your supervisor and you're telling them, you know, I'm installing the tool. You know, they're like, it's not working. What's happening? You know, and you're spending 2 days just installing the tool or setting it up. You know, that can become a big challenge to your productivity. Right? So yeah, so this is sort of overview, reproducibility. It works on my machine. Yeah, that's fine. It works on my machine. And you know, you hold that dear. You know, I know times when like, oh, don't touch my computer. Like, just leave it as it is. Yeah. And tell me to install a new thing, I'll be like, no, witchcraft. So we build our computer systems the way we build our cities. Okay, over time, without a plan, on top of ruins. And I really like that quote. I had not seen it, and you know, I came across when I was going through field slides. This is really close to the truth, right? That often you start on a project, you get on it directly, whether that's in your C drive or your home directory, you start working and you'll install tools on that environment, and then you realize tool Y doesn't work. Now we need to think about what am I going to do? You'll come across install packages and so on, and things will not work, and sometimes something just works and you want to retain it as it was, okay? And often big tooling systems, good languages, good environments are all very much dependent on steps and actions and things that were done previously. So you pretty much building on other people's great work, and you aim to improve them. So the solution is to make our machines as similar as possible and to start from fresh each time. And this is important. I don't know how many times I've had to delete an entire script, or start all over again. And sometimes you can bet in that cycle where, you're getting things getting very improved. If you worked within the SARS-CoV-2 world, you'd get your tools being updated by the day. If you work with nanopore data, for example, you get revisions of your base caller every couple of weeks, every other month. And the question is, I got this work that I started, I sequenced some reads in January, and now there have been like 4 revisions on the analysis. How do I work with that tool, right? So that becomes quite a problem, and you got to think about solutions. Luckily, it's not unique. That's what pretty much everyone is going through or has gone through, and communities have grown to think about how you set that up, and one way that was set up through Python is Conda and the Conda environment, and we're just going to go through that in a bit. I think this is what we were talking about. The package management in Python was a mess. I think it's still sort of a mess. So here you got easy install. We got pip. We got the Python path. You can prepare your path. And if that works for your Python, you can say exactly what Python version you have, and you can install multiple versions of Python. You got an Conda that comes with the pip. You got Homebrew for those of us who are familiar with Homebrew, particularly if you're working with OS 10 or Mac OS now. And you get into this cellar. You got the Python, the OS distributed Python that you can't change. Because if you do that, everything doesn't work anymore. You don't want to mess with your operating system Python, and you can't upgrade it, okay? And you may have a new version of Python. So this is XKCD, really great cartoons, and sort of captures that very well, right? So introduction to Conda. Again, what is the problem? In a sense, I've sort of alluded to what it is. And we want to avoid the dependency hell, essentially. And often I want to run software A. That could be Nextclade. And it turns out that it depends on software B, C, and D. And software B depends on software E and F. And software C depends on G and H. And D depends on I and J. That's just exactly what I sort of said earlier on. And when you get that kind of scenario, it becomes really tricky and difficult to have an environment and work on multiple projects. So often as a bioinformatician, you will come across different tools. So for example, I may be working on rotavirus data or malaria, and there's a specific tool that says you need to install version 2.7 of Python. And I need to work on that. So how do I resolve it? And at the same time, I'm given a project on SARS-CoV-2 that says Augur only works with the version 3 of Python. So how do I deal with that in my computing environment? You are the system administrator. You are the software developer. You are the end user. Okay. So package management. Okay. So enter Conda. I don't know why they called it so. I'd love to know the history. And it's a distribution of Python and R that aimed at scientists, and the idea is to simplify package management, right? So when you install an Conda, you get Python, and you get other common scientific packages, and that's the Conda. It's language agnostic. It doesn't matter, what's on it. You can install Ruby, you can install Python, multiple versions of it. So when you install that environment or this tool, you get a package manager that is specific for Conda, and you get an environment manager. So that means you can have multiple environments in your computer, and you can move about them as we'll see. So Conda is quite a large package. might take a bit of a while to install sometimes. And therefore comes Miniconda, which is simply Python encoder. Okay? Because this comes with all the bells and whistles. Anaconda comes with all the bells and whistles. And sometimes that's not what you need. You just need a base minimal environment that will work as well. And then you can go about setting up your environment. So Conda basically is now thousands of tools that are available. And what they've done is that they got these channels that are places, or you can think about locations where the packages are hosted. So they will be hosted on servers out there. They will be described as channels. You will add a channel onto your environment, and you can pull and access packages and their installations from those channels. So for bioinformaticians, there's Bioconda that has tons of bioinformatics software. And a lot of people went on to develop and make their packages available from Bioconda channel. The CodaForge is a much larger community initiative aimed at packaging and providing packages for other utilities as well. So often you want to sometimes include both of them so that you can pull from a large array of packages. And channels are such in an order. Okay? So how you declare how to install, I think we're going to have a look at that. How we set up that is going to give us priority on where you look for a tool first. And sometimes I think I've seen tools that are available on multiple channels. And that can present a problem when the version that you need is on a priority channel that you've set up on your environment, and therefore you can't find the package that you need because it's on a channel that has lower precedence. Okay, so important to check that. I think here is a graph. I think Phil wants to show us, got the number of downloads, and these are different packages. You can see some tools have been downloaded close to 2.4 million times. That's really, really important. And the HTS-lib, all of us depend on it. Some PySum, BSF tools. These are like your go-to tools and libraries, and that's really great. Okay. And because of this, here, the success of the Conda environment, so what Conda does in the background is that it tries to resolve all the dependencies inherently, and therefore when you say I want some tools version whatnot, Conda goes into the background and will try to look for all those tooling and get them and get the correct dependencies, and that can slow things a bit. Okay. So comes Mamba. I think everything is all named after snakes. I think it has to do with Python itself. Like they're keeping it true. So Mamba, is a much faster version of Conda, and it tries to resolve the dependencies. But I think initially, it was just made to, the packaging was meant to work. It works really well, ran into headwinds, and now you got to think back, take a step back, and do things correctly. And I think that's very reminiscent of how bioinformaticians work, and I work that way sometimes. So I just need something to work initially, and then it works so well, and then you start to depend on it, and then you realize that it's not doing what you want. Now you run into other issues, and then you got to sit back and now think, don't I spend a week just making this work, this workflow work, because I'm so much dependent on it. Okay, so what is the current state of software environment on the computer? What is the desired state of the software environment? Make an upgrade plan that allows installation of new software without breaking existing software. So two things slow down Conda, and that the increasing number of packages installed on your computer, yeah, and an increasing number of packages available for installation. So this is on the, from the channels, right? You've got an increasing number of packages that are available, and that means that you got a lot more dependencies to resolve, okay? And your software, your tooling, your environment itself can grow complex. So I have to be honest, there are times I've had to delete my entire Conda environment, and that's really easy to do without affecting your base environment, and start all over again. And because I know the tools that I want, and sometimes I've closed down projects that I no longer work, so I don't need those tools anymore, I start all afresh. And that sounds much easier to start all afresh when you got an environment that you can manage, and when you got a tooling that you know works and will be reproducible, okay? Yeah. So Mamba is a drop-in replacement for Conda that is much quicker, and you just say Mamba install, you get your Conda environment. I think we'll see that in a short while. And you got Mamba create, and pretty much it's a drop-in replacement. So where you'd have used Conda do this, Conda does that, you simply replace it with Mamba. And I hope I'm pronouncing that correct. I'm pronouncing it the Kiswahili way, Mamba. Okay, I don't know what does Mamba has its root in Swahili? Right? Yeah. I get a couple of nods from East Africans. Yeah? It's a crocodile. No, but there's Mamba, the snake. Like the black Mamba and, yeah, sorry, yeah. So I think the important thing is that it uses this library here, which is a C++ efficient toolkit to resolve the dependencies. And the code is very optimized. So this, so if you're familiar with the scripting languages, of which Python is one, you know that it's not a compiled language. Any one of us who knows the differences between scripting languages and compiled languages? Yeah. So most of Python is written in another language like C. So you got C Python. I think that's the main one. And you can get multiple implementations of Python, I think, in other languages. I'm not sure. I did see something. I think they're even rewriting it in Rust now, something. I wouldn't be surprised. But you always run into issues when you're working with scripting languages. They tend to be a little bit slow, okay? You almost always want to go down to languages like C or C++ that are much more closer to machine language, and that you can have very optimal and optimized code. Okay, so that's what they use, and the idea is to then make everything a bit faster. So Conda environment. Conda is a tool, it's a platform, but it's also an environment manager, right? And the environments, okay, also called virtual environments, yeah, are a way to have a separate and independent installation of software on the same computer. Okay, so if you use Python, for those of us that have used Python, we know about virtualenv, right? Which again allows you to have multiple Python environments, right? So Conda manages multiple environments for you, and you can have very isolated, again, environments. So, or rather, sandboxes, okay, where you can install your packages, you can do specific analysis, you can have all the dependencies, and Conda will manage that for you. And the way they work is by modifying the path. Yeah, are we familiar with this keyword? If you're in Linux, worked with Linux before, you'll be familiar with the $path. Yeah, which is declares your path, where your software endpoints and your executables are. And once you prepared that and you modify that by either adding a new path and making those environments available, you can execute your tasks or your software. So the advantages of environments is that it's easier to install software, and you don't have a lot in that environment. So you can declare your environment, install and put all your dependencies in there quite easily, and you're not polluting your global namespace or your OS namespace. And you can have different versions of the same dependencies. Yeah. So if I wanted to run an old tool that depended on a particular version of some tools, I can simply install that, and that does not mean that I can't have another environment or another sandbox or virtual environment that uses a much more recent version of the same tool. Okay, so when you install Conda, your default environment, it creates an environment. It's called base, and I think that's what Edwin is set up for us. And often you don't want to install things on base. Okay, you want to keep it clean, and I think we will come down to that. Okay, so often you will set up a new environment in base and you can set up multiple virtual environments, but that will be your default environment, right? So what does what do you want your base environment to look like? Yeah, you got this here, and what looks like heaven, nirvana, you know, your Zen space. So you can have something like this. Okay. Sometimes I like this. Often this is the reality, you know. This is yeah. Okay. So and while asking your base environment, I think if you're not using a package manager, this is what you have, regardless of how shiny your laptop looks from the outside. Most often, this is what you have. So you get a dependency hell, you got a cluttered system, you don't know where things are, you got software installed, you know, in your base home directory, you got other tools in Cellar, others in user bin, and so on and so forth. Okay, so essentially we want